This episode of CppCast is sponsored by Undo Software. Debugging C++ is hard, which is why Undo Software's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo-software.com to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. Episode 43 of CppCast with guest Matt Godbolt, recorded January 27th, 2016. In this episode, we talk about a new open source project from Microsoft. Then we talk to Matt Godbolt from DRW. Matt tells us about his interactive compiler Explorer and what you can learn from it. Welcome to episode 43 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right, Rob, how about you?
Doing pretty good. It sounds like we're both feeling better, so that's good.
Yeah.
Yeah. I'm getting ready to move again.
Right.
It'll be in just 2 weeks, but I think we're going to be able to get by without much interruption to the show, which is good. Since
Very
it's
good.
Just across the town move.
You moved more times in the last year than I've moved in the last 14.
Well, this should be the last one, at least for a very long time. Hopefully I get to stay there for at least 14 years. Okay. Well, at the top of every episode, I like to read a piece of feedback. This week, we actually got a lot of comments on the CppCast website after last episode. I guess because we kind of put out a call for guest suggestions.
Yes.
And this one comes from Vipul, and he says, may I nominate Jens Veller, C++ developer well known for community building at Meeting C++, for appearing as an episode guest. We actually already reached out to Jens, and we think we should be getting him on sometime in March. And he actually just emailed me the other day to suggest a couple guests of his own. And some of the other feedback responses we got, there was some suggestion to talk to some guys from Google who are working on a language extension called Halide. Did you see this, Jason?
I did not.
Yeah, a programming DSL called Halide, DSL embedded in C++, allows programmers to specify an algorithm with the functional programming paradigm, but also allows them to specify a schedule for execution yielding native C++-like performance. It's very easy to get your algorithm running on a GPU. Sounds interesting. So I'll have to look into these Google developers and see if I can get in touch with them.
So how do you spell that?
Halide?
Yeah.
It's Halide.
Okay. Interesting.
Anyway, we do appreciate all the comments. Like I said, we got several after this last episode, and keep the suggestions coming in. You can always email us at feedback@cppcast.com, or you can reach out to us on Facebook or Twitter. And again, we always like to get those reviews on iTunes as well. Joining us today is Matt Godbolt. Matt is a developer at trading firm DRW. Before that, he's worked at Google, run a C++ tools company, and spent over a decade in the games industry making PC and console games. He is fascinated by performance and created GCC Explorer to help understand how C++ code ends up looking to the processor. When not performance tuning C++ code, he enjoys writing emulators for 8-bit computers in JavaScript. Matt, welcome to the show.
Thank you for having me. Nice to be here.
So have you worked on any games that any of us would recognize?
This is always the question I dread when I say that I've worked for so long in the games industry. So it was, I think, 1997 I started working in the games industry. So the games I worked on were like PlayStation 1 games. Okay. I think the only one that was even remotely successful was a game called Croc, Legend of the Gobbos, which certainly kept the company I worked for afloat for a few years. But I worked on one of the SWAT games. for the PC, and I've worked on some. I worked on my favorite game to work on was a Dreamcast game, but seeing as nobody bought the Dreamcast, no one has bought the game either.
Right.
Well, some of my friends in college were big Dreamcast fans.
It was like the Betamax of its day, or Betamax of its day. You know, it was technologically superior. It was great to develop for. There's guys at Sega who were behind it were always quick to answer questions, but it just didn't win. It was like dead on arrival. The PlayStation 1 was too far ahead.
Yeah. Okay, well, we got a couple news articles to talk about, and then we'll start talking about GCC Explorer. So the first one is Microsoft just released CNTK, its open source deep learning toolkit. And C++ doesn't actually directly mention it all in the article, but they link to their GitHub repo, and you can tell that it is a C++ repository. And they're comparing it to a couple other deep learning toolkits that have been out already, and the performance of Microsoft's solution is just off the scale compared to these other ones. Jason, you have anything to add to this one?
Not really, because I feel like I just don't really understand how I would use a deep learning toolkit.
Mm-hmm.
Like, I don't know what does a normal person do with this? I have no idea.
It sounds like it's, used for speech recognition and image processing, and it's all, pretty advanced stuff that I'm sure is going to become more and more kind of commonplace in the industry as we move forward.
What isn't it?
As best I can tell, deep learning seems to be a way of us sort of accelerating the heat death of the universe, because as far as I can tell, data centers are being filled with machines, racks and racks of machines, which are now being filled with racks and racks of GPUs to support this kind of thing. So it's almost like, it looks like it's a problem looking for a solution looking for a problem. I guess some firms are using it for, like Google and co are using it for great image recognition stuff, but I've yet to see anyone in a normal company suggest it as a solution to something.
Well, they kind of ominously say throughout this article that it was developed to meet Microsoft's internal needs, which makes me there's too many images.
Although, let's be fair, Microsoft are like a big turnaround. Recently with their open source stuff, we'd written them off like 4 or 5 years ago, and they're starting to make a comeback. So I applaud the effort of them opening up things, and hope that they continue to do so.
Yes, I totally agree. But between your image of the heat death of the universe and the mental image I already have of Skynet being developed, I figure these have to lead to the end of the planet somehow.
Yeah. That's interesting. I just went to look at their GitHub repo again, but apparently GitHub is down for maintenance right now.
GitHub has been down for the last half hour, actually. Twitter has been exploding with everyone raging about it. So yeah. It's what else have we got to do on
talk about signs of the apocalypse.
Right.
Well, when GitHub's not down, the CNTK is fully open source if anyone has any interest in seeing how a deep learning tool is implemented in C++. Yeah.
Yeah.
Okay. Next article is from Dave Sankel, one of our early guests on the show. And he's writing an article about his proposal to add language support for pattern matching and variance. And it's not for C++ 17. It'll be for C++ 20, maybe, I guess. It will be the next revision. But it was really a good article, explaining his proposal in depth, showing lots of examples of what language-based pattern matching and variance will look like.
Yeah, and it looks like it would require some language extensions for kind of operators that don't currently exist, unless I misread that.
Yeah, I think there were 3 new operators for dealing with variance. Alternative, discriminator. Is there another one?
Yeah, I don't know. There's a lot of meat to that article for anyone who goes to read it.
It is a very meaty article, but definitely well worth the read.
And a fair bit of discussion afterward, too, in the comments.
Mm-hmm.
Definitely. This is something that I would like to have, but the the proposal as it stands does seem like an awful lot of new keywords and a lot of new semantics and things like that. And I know, Bjarne is particularly averse to adding any kind of extra keywords to the language in places where it's not totally unambiguous. So all of the kind of names that they're picking as well are exactly the kind of names that people who are writing variant libraries now are using as function names. So making them operator names seems like a problem. But I've tinkered in Rust, and one of the things I did enjoy most about Rust was the ability to do sort of this deconstruction on types and enumerated values and things like that. So I think it would be a welcome language addition, but needs a bit of work, I think.
Yeah, it's a very good point with the operator names. There's no way you could have a function or an operator name to extract, because everyone's code base is going to have some function name with that name.
Yeah.
Right. It depends if they're going to play the tricks they did with things like override and final, where it's only a keyword in a particular place. But it's not clear to me that you could do that with an operator. Right.
Okay. And then this last article, also coming from Microsoft, this one from STL about the VS 2015 Update 2, which is not out yet, I believe. I think we're still in Update 1.
Yeah.
But when Update 2 comes out, the STL is going to be C++ 17 feature complete, which is interesting since C++ 17 isn't really out yet. But
so Microsoft used their deep learning toolkit to invent time travel.
Well, they're basically looking at all the working papers in C++ 17 and seeing what they think is going to be in C++ 17, and the STL is going to support all of those features in addition to all the 11 and 14 features.
Yeah, I would be.
Go ahead.
Ahead.
They're going to be scared by the Clang guys who take great pride in being in every meeting at the CPP conferences and things, and usually have finished the features that have been agreed by the end of the night. They do these hackathons through it. It's a marvel to watch.
That sounds pretty amazing.
It does.
What were you going to say, Jason?
Oh, I was just going to say I'd be surprised if any of those proposals change very much. What they've implemented will probably end up being what's in 17.
Yeah, at this point, I think 17 is getting pretty locked down. Yeah. I don't think we're going to see much change at this point. Okay, so Matt, let's start talking to you. Can you kind of give us an overview about what this interactive compiler explorer is and where people can find it?
Sure. So you'll forgive me if I call it GCC Explorer, because that's what I used to call it forever. And then as I added more and more compilers, the name got more and more inappropriate. So I'm trying to rebrand it as Compiler Explorer now. But GCC Explorer is a website that you can get to at gcc.godbolt.org that basically gives you a drop-down of compilers and allows you to type in your code on the left-hand side in the left-hand pane, and then interactively compiles it and shows you the disassembled view of your code on the right-hand side. So the reason I wrote this is I found myself, especially with the new C++ OX, as it was then, features, wondering what the actual cost of the code that I was writing was. And obviously the best thing to do is to run your code, profile it and whatever. But sometimes you just want that sort of feedback loop of like, well, how does the compiler do this? Which things disappear? Which things are actually elided by, return value optimization? What does move construction do? And certainly for tiny little snippets of code where you're thinking, should I pass a std string by reference? Should I pass it by value? You can type in a little bit of code into the Explorer and then just see what the assembly looks like on the other side. And so it started out life as a kind of bash script that I wrote, where it was just compiling and then dumping it on the screen continuously in like every 2 seconds. And then I realized that, hey, this is the age of the web, and I should really learn how to write a website. And before you knew it, it was up and running. And then I added loads more compiler support to it, so we now got basically all the versions of GCC ever. We've got ARM versions in there. We've got Clang. I even managed to talk Intel into giving me an educational license for at least one of the versions of ICC. Oh. So one of the more interesting things to do is to put the same piece of code in, crank the optimization up to top level, and then drop down between compilers and go, well, how would this compiler do? How does this piece of code vectorize okay on this compiler, or do I need to give extra hints and stuff? So it's been a fascinating tool, and for me personally, and the feedback that I get from people now is that they use it now almost like does my code compile? So I have a pal who works on the Unreal Engine under Windows. He needs to be able to support all the various different compilers. And for various little idioms, he'll chuck them into the website and then just basically cycle through and make sure that A, they compile, and B, the code kind of looks about what he would expect it to look like. And
so you have PowerPC and AVR and x86 and ARM on here. How do you accomplish having so many different targets? Are you cross-compiling?
Blood, sweat. Yeah, it's so there's the whole thing's open source, so you can go and have a look at it on GitHub when it's up. And there's actually the magic and trickery I used to build all the compilers and build all of the Docker images that it runs on. So behind the scenes, it runs on an Amazon instance, and that Amazon instance then embeds several Docker images. Each one has a different version of an operating system for which I could find a version of the compiler for that particular architecture or of that particular age to install into. And the reason for that is I tried. There's a thing called Crosstool, which is a fantastic set of scripts that allows you to do cross-compilation for all these different things, but it's extremely flaky, and I didn't want to invest too much time. So I'll be honest, most of the things that are on that list are things where I can find, the installation packages for, say, Ubuntu 10, and that's the one I install on a Docker image of Ubuntu 10, and then there you go, there's all the compilers. So it's the bane of my life, though, because the number one feature is, can you support compiler X? So I get an email, and then I'll have to hunt down a way of getting it, and then I'll have to find a way of crowbarring it into my ever-expanding Docker containers and going from there.
Well, see, now I
have actually built them. Sorry, go on, yeah.
I almost put in a support request myself to support Vim bindings in the code editor, but I figured that was outside of the scope of the project.
No, that shouldn't be too bad. The code editor is this marvelous little thing called Code Mirror, which I recommend anyone who is thinking of doing anything on the web. I mean, I barely touched it. The only thing I've done is I've given it an assembly mode that understands how to syntax color some of the more obscure things that appear on the right-hand side. But it's a fully featured editor. It supports, if you let it, it supports code expansion, auto-completion. It supports parsing ability. It's brilliant. So there are Vim bindings for it. I haven't put them in there because no one's that crazy, right? I usually paste my code into it.
I actually find the project kind of addicting myself. I just use it to see, what does this code do? Like you were saying, but I edit live in it and watch it spit back the results.
Right. Yeah. So you're the one who's hammering my my servers, right?
Yeah.
That's okay. That's what they're there for. But it is amazing, actually. And I mean, a passion of mine, as you can probably tell from the other things I get up to, is more like the low level of things. And it does surprise me how isolated we have become from the processor that's inside the machine that's running our code, even in C++. And, I love C++. I love the things that are going on in C++ 11 and 17. And it's becoming our higher and higher programming language. But I absolutely love the fact that you can still drill all the way back down to effectively just C. And if you really don't mind, you can open up an inline assembly block and just keep on going down, right down to the bottom. And I don't think there's a single other programming language. Maybe Rust is getting there, but there's no other programming language that lets you do this. But even with that in mind, I think there's a surprising number of very good programmers who don't really know how the rubber hits the road. And this is another thing to show them. It's not that scary. I vividly remember having a guy come in back in the games days, fresh out of university, and we had a crash in code, and we couldn't work out what was going on, so I dropped to the disassembly view, and he looked at me like, "What are you doing? This is witchcraft." I'm like, this is what your program does. If you don't understand this, then you don't know what the computer's doing. And he looked at me like, "I don't know assembly." I'm like, at the time, I don't know x86 assembly too, but you can marry up what the instructions are with what you're trying to do, and you can probably work it out. And, we did. And I think that everyone needs to have that experience. Everyone should know that it's accessible. It is something you can do. And it's important to understand what the computer's doing so that you know how to not do silly things, and also how smart the compiler is at guessing what you actually meant.
Let's talk a little bit more about that. I mean, what types of things do you think C++ developers who don't really go down into assembly very often can learn from using this kind of tool?
Right. I think some of the things most people have sort of internalized at some level, the passing of things by const ref as opposed to by value, Although, again, with the caveats that I guess that's the C++ watchword, right? There's always a catch, right? There's sometimes when that's better to do, and sometimes when that's not. Unnecessary copies of objects taken sometimes come out of that. What else is type of things? Pointer aliasing is always a surprising one. And I mean that in terms of like, if you sit down someone with a little loop going, for I equals 0 to a million, add up some things, and then you look at the assembly output and you go, well, why on earth is it like reloading the loop counter every single time, or the thing it's comparing the loop counter against every single time? And you're like, well, yeah, that does seem weird. It should put it in a register, it should unroll it or whatever. And then a compiler author will sit down and say to you, unless the compiler can prove that the innermost part of the loop is not accessing through some circuitous way the variable that the end of the iteration is stored in, then it has to assume it's changed every time. You're like, oh, I hadn't thought of that. Now that doesn't come out from just straight looking at the code. That just someone has to tell you about that. But there are some surprising things like that that come out, I find.
So do you have any favorites for other than that, for surprising things that maybe other users have pointed out or that you've learned through the tool?
I guess, there's a couple of examples that you can do on the drop down, and one of them is the just a simplistic sum over arrays. And in order to torture the compiler into generating the code that one might instinctively think it could generate, it's amazing how many funny little underscore restricts and how many funny little intrinsic you need to do just to sort of cough politely and say, no, this is what I meant. You can trust me that this is not aliasing. You can trust me that the pointers that I'm going to give you are aligned on the natural boundary for the thing that I'm passing in. And then it will generate a lovely piece of vectorized code. But you really do have to go out of your way to do that. And I think unless you're actively disassembling your code, or looking at the app or single stepping through the debugger, you just don't know what's going on.
Right.
Interesting.
So what kind of response have you gotten from users using the tool?
It's been overwhelmingly positive. It's surprising how many hits I get and how many people are interested in what their code is doing, which again is the thing that I really enjoy hearing about. Most of the requests are for things that are now in the bug tracker, things like a diff side-by-side sort of diff view. This is a way that I use it myself as well. It's like, should I pass 03 or minus 02 for the compiler options? How much difference does it make? It would be nice to be able to write the code and then have a drop down and choose like two versions, maybe even two versions of code as well. Like I would like to do either this way, or maybe a minus capital D to the compiler to switch between two like inner blocks inside your loop, and then be able to like look at a difference view of the generated assembly and see if you can see what the difference is between the before and after. So forever everyone was asking about link time code generation, which was a big hole in the way that it was working before. So the way that it used to work was that it would compile the code and use the flags to GCC or the various compilers to just output the text of the assembly, and then it would send the whole lot down to the client, and then the JavaScript would do all of the filtering and whatnot. And then my Amazon bills were getting more and more and more as I was sending more and more terabytes of data of like effectively white space. I mean, you guys know how big these things can be,
right?
So I finally bit the bullet, and now all that's done on the server, and now also optionally with the binary view for the compilers that I can support, it actually compiles it to the object file, and then compiles and links it, and then disassembles it back out again, and then applies some filtering, and then gives you back the end results, which gives you like the opcodes as well, so you can see how many opcodes each instruction encodes to, and more importantly, allows you to turn on things like link time code generation, which is very interesting. Again, the compilers are so smart these days. It's amazing what they can do. And when you lift the lid of to them and say this is the whole program, go nuts. The stuff they do, like the newer GCCs and their amazing devirtualization that they do, speculative or otherwise, it's just great. It's nice to watch, but I guess the most feedback I'm getting at the moment is I clicked the button for link time code generation, and now all I get was an empty main function. I'm like, well, yeah, the compiler was smart enough to realize that your code had no side effects whatsoever, and so it just threw the whole lot away. So there's a sort of black art to generating the code and trying to find a way of tricking the compiler into not throwing it away.
So you've mentioned that you're running all these builds on an Amazon server, and it seems like the system responds very fast. So is this, how many servers do you have running, and is this costing you a fortune to keep it up, or what?
Thankfully not, no. At the moment I have one server up and running, although it can scale up to 4 on demand. That is the very occasional times it makes anywhere near the beginning of Hacker News's a Hacker News article. Then it scales up. But at the moment, it's just one. It used to be like the cheapest tiered Amazon server you could get, but that was a bit choppy. So I've gone to a slightly higher level, and it's not costing very much at all. But there's a lot of caching that I try and do. Obviously, a lot of people land on that page and they load up the examples. Or while you're typing, you go back and forth on things between 2 different variations of the same code, and so it's useful to cache that on my side as well. So. I'm surprised at how quick it is too. I'm even more surprised that touch wood, nobody has hacked it yet, because running a full compiler on demand with arbitrary pieces of code that people are typing in gives a kind of a large window of vulnerability to those who have bad intentions. But I have tried my best on that front, but I'm sure if a security expert is listening, they can blow a hole in it and go for it, I would say. It's a throwaway instance, so there shouldn't be anything on there if it does go down. It does annoy people. But
it doesn't actually execute the compiled code, correct?
Correct, but you'd be surprised how many command line flags there are to GCC for loading dynamic modules, or so. This is in fairness, we've had a few people attempt to break through, and the normal way is to do something like pound include etc password, and then of course the error message prints out the first line of etc password, and you're like, oh, look, I can hack you now. I'm like, well, not really. And then of course, so I put in the obvious, let's just check in the server that there's nothing silly in the includes. And then of course C++ being, or rather I guess this is C, being as awkward as it is, there are a million ways of getting the preprocessor to read a file. You can pound define foo as quote /etc/password, and then you can do pound include foo without quotes, and it will expand the macro, and off you go. And there's a lot of ways of obfuscating it. So eventually I bit the bullet, and now I run all the compilers with an LD preload, which for the more Unix folk among you is a way of effectively preloading a shared library before an executable runs. That allows me to hook all of the operating system calls for file opening and reading and writing and creation, whatever like that, and then I have a little thing that just goes, I know the kind of files that GCC should be opening. Anything else, deny. It's very, very simplistic though, so I'm sure anyone who's listening can crack their way through it, and please contact me if you have a better idea.
Oh, that sounds like a pretty creative idea to me, but I'm not an expert in these things.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. You have an extensive test suite, right? You're using TDD, continuous integration, and other best practices, but do all your tests pass all of the time? Getting to the bottom of intermittent and obscure test failures is crucial if you want to get the full value from these practices, and Undo Software's live recorder technology allows you to easily fix the bugs that don't otherwise get fixed. Capture a recording of failing tests in your test suites and debug them offline so that you can collaborate with your development teams and customers. Get your software out of development and into production much more quickly, and be confident that it is of higher quality. Visit undo-software.com to see how they can help you find out exactly what your software really did, as opposed to what you expected it to do, and fix your bugs in minutes, not weeks.
So you have other versions, right? There's a Rust Compiler Explorer also, is that correct?
That is correct, yes. So there's rust.godbolt.org, there's go.godbolt.org, and there is d.godbolt.org, which I think you can probably guess which each of those do. But in terms of the number of hits, Rust has the most, because I think it's the most popular. Even though Rust has its own kind of interactive Rust compiler, which can generate assembly and looks probably nicer than mine. So I'm surprised the number of hits I get at that. I think that's a testament to the growing popularity. Go is kind of next, and then poor D is still lagging a little bit, even though I'm a big fan of, well, certainly Andre and what he's up to, but I feel maybe the ship has sailed there. We'll see. I think it's healthy to have many different languages to choose from, and with Go Rust, D, and C++ all vying for position. I mean, my thoughts are that things like Go and Rust and D are what have accelerated C++'s development of recent times with, OX 11, 17. Mm-hmm. We've seen that there's somebody coming up behind, and they've got their sort of sights set on systems programming languages too, and performance and things like that. And so the complacency has dropped. So I'm very much in favor of competition, healthy competition.
Well, you've mentioned all the big ones there, Go, Rust, D. What have you learned anything from these languages that you think should be brought into C++, or any ways that you think they will outpace C++ in the near future?
I mean, not from my direct experiences in GCC Explorer. It still seems to be, Compiler Explorer, I should say now. It does seem to me that GCC is winning, certainly in the open source compiler stakes, the code generation game. I have yet to see anything come out of either D or Go or Rust's compiler that sort of competes with it. And even compared to Clang, I mean, I love the Clang folks. They're doing amazing work. And again, they've kicked GCC along by basically shaming it with the error messages that they generate. But their code quality is still not quite there. I mean, this is based on my samples of things that I'm interested in, which are very numerically intensive, very intrinsic-y based anyway. So maybe I'm completely skewed, but yeah, code generation is not as good in the other languages, I would say, just yet. But there's something in terms of the features that the languages have themselves. We've already spoken earlier about the pattern matching, which I'm becoming more and more of a fan of variants in C++ in general. It's something that we are starting to do more and more in my day job to sort of match to get the job done. But having pattern matching would be just so much nicer than the sort of the boost static visitor kind of approaches that we're having to do at the moment. It's just not very ergonomic to use, and I think that puts a lot of people off. So I'm looking forward to that coming. And obviously, the type safety aspect of Rust is, in equal amounts, frustrating and amazing. Frustrating because if you get it wrong, the compiler gives you a 300-line error message that you have to decode. It is right, though, and it would have been a problem at runtime, but I'm used to finding the problems at runtime rather than at compile time, and I'm pretty good at finding them now, but I'm less good at reasoning about why the borrow checker's not letting me do something I think I should be able to.
So it's like debugging template metaprogramming compiler errors.
I guess so, although no, nothing's as bad as that. I guess that's another sort of strength of C++ in general, is the fact that you can pretty much write code in any style you like. I can sit there and I can write my little intrinsic laden maths kernels, and some other guy can write an almost functional style language approach using template metaprogramming, and then we fight over the compiler errors, as you say, or rather the compile times, which is obviously something I think, again, the other languages have over C++, is that their compile times are usually better. I guess Rust is actively working on there, and it's still very early, but that's probably the only thing that's comparable to a big C++ template fest.
The D claims are that it creates code almost as efficient as C++, but almost as fast as using a scripting engine for compilation.
Right. That last thing is definitely true. I mean, it is very fast. As is Go, though. I mean, Go is super fast in terms of compilation time, and that was another stated goal. And I think, if people are like me, you've grown up writing C and C++, we've probably learnt, or rather, we've sleptwalked into the case where our compilations are getting longer. I started out writing assembly, and that was like instantaneous. Then C, and that nowadays if you pull down an open source project that's written in C and you type make, it's like boom, oh, it's built. What's going on there? How do we get into this stage where we accept like a 25-minute build as being like just one of those things that you have to endure when you're writing in C++? So it's interesting to see other languages taking a step back and going, we should fix that first. Developer productivity trumps almost everything.
So you mentioned your day job a little bit there. Is there anything you can talk about? I mean, we've had desire to get someone on to talk about high frequency trading and what that industry is like as a C++ developer. Right.
Obviously, there's a limited amount that I can talk about.
Sure.
The industry as a whole is secretive, which is an interesting thing. So prior to this, obviously, I worked at Google, and they're also secretive, but in a different way. The trading industry is an interesting one. I mean, obviously, a small selection of what we do as an industry is very time critical, very latency sensitive, and people are prepared to go to extraordinary lengths to reduce the time it takes to do things. And that often means writing close down to the metal. Assembly, C, C++, obviously are good choices there, but there's still an enormous amount of stuff that we do for where Java, Python are still very good choices. And then as far as I can tell, the really fast people are starting to look beyond conventional hardware and conventional C and C++, and they're going to like extreme, like designing their own hardware and things like that, which is fun and interesting sounding, but my take on that is that you always still need something to talk to that hardware, and that means that you need to understand, again, at the basic level, what hardware in general does. And I feel that C is one of the better languages. C and C++ are the better languages to be able to learn those techniques, understand it. I mean, I've spent time, trying to explain to dyed-in-the-wool Java programmers about we don't parse a lot of the data that's coming in. There is no parse step. I just cast it to be the right structure and read the data out of it. It's like memory is a slab of bytes, and I can choose how I interpret those bytes however I like, and it doesn't cost me anything. There's no conversion. There's no anything. And they look at me like, what do you mean? And I'm like, but that's how the computer works. You have to understand how the computer works. And I think, I mean, certainly from our company's perspective, we're always looking to hire smart people. So I get my little micro plug in there. But it's becoming more difficult to find people who are. I think Martin Thompson coined this term, the term of mechanical sympathy, like understanding that in order to get the most out of something, you do have to understand how it works at a sort of deep level, even if you're going to be writing in Java or Python or whatever, and C++ gives you a good preparation of getting there. I have there's a presentation that I did for the GoTo conferences on how the computer really works, which is like lifting the lid even of like what the instruction stream does under the hood of the x86. And I was able to find an example of writing something in Python that caused the branch predictor to go wrong, and I could demonstrably show that even in Python you can write code that causes bad performance issues if you don't understand that like 12 layers of complexity beneath where you're writing, there is actually something you might need to at least know exists. I'm not saying every Python programmer needs to crack out like some textbook on how branch predictors work, but you have to be aware that it's there.
So are those talks available online?
Yes, I think if you look on YouTube, there's go-to conferences, or just type my name in. I think you'll probably find them there.
One thing we didn't mention in the news is that the C++ Now 2016 submission deadline is coming up on 2 days from now, which I guess is the day that we're going to air this episode, probably.
Yeah.
But anyhow, have you spoken at any C++ conferences, or have you considered it?
I've considered it. Yeah, if I had enough of an axe to grind, my passion is in a particular area, as you can probably tell, and so, and although I've been variously described as C++, someone who knows C++ pretty well, as I've been doing it so long, I've never really had a burning ambition to proselytize for the language. But I guess I would consider it.
Well, they're fun conferences. Just thought I'd throw it out.
So you've had experience working on other industries too, embedded systems, AAA video games, which you mentioned during your introduction.
Well, what we like to think of, everyone describes their games as AAA. The public ultimately gets to decide, though, I think.
Is there any other interesting experiences from some of that past work that you'd like to share relating to C++?
Oh, that's
might be a big question. Yeah,
it is a big question, isn't it? I mean, obviously, pretty much every game ever has been written in C and C++. It's, again, for all the reasons we've talked about, it's pretty much the same as the trading industry. There is a certain set of things you want to get done really, really, really fast, or with very low latency, be it send more, react faster to input from the exchange to send more trades at the right time, or be it getting more explosions on the screen or whatever. There is something about doing things efficiently and fast. That said, I think there are extra tricks in the games industry where you have the luxury, certainly in the console world, you have the luxury of having the same hardware in front of you as the people at home are going to have in front of them, which means that you can go to town on specific optimizations. And to an extent, I have the same luxury now. We're in this situation that at work, if we need to deploy something, we buy a particular computer that I then target and I put it in a data center and it runs my code, right? So I can assume that the particular instructions are available or memory is going to be laid out in a particular way or whatever. What scares me is like doing anything like that for like modern PC games where there is such a heterogeneous, I can never say that word, environment of computers out there, and each of them have different RAM, different speeds of RAM, CPU features, GPU features. That doesn't leave much space for like creative solutions to problems, which is something I've always enjoyed. Is like finding tricky ways of doing stuff. This is not specifically a C++ thing, so forgive me for a second, but writing a game for both Xbox and PlayStation 2 at the same time was fun because they had wildly different feature sets, and trying to make the rendering system of one work commendably well on the other one was an exercise in like, well, if we tell the graphics card that it's actually a 16-bit texture even though it's an 8-bit texture, and then we draw tiny little triangles over here, that just picks out the red color from the texture, and then we can use that as an index over here, and stuff like that, stuff where someone has to sit down and explain it on paper and draw it out, and you're like, oh yeah, you can do that. Oh, you said you couldn't do bump mapping on a PlayStation. It's like, well, it turns out you can if you have enough smart people working on something and a constrained problem that isn't changing. Wow. Which I guess is computing, right?
Right.
Well, so you've got a few other toy projects on the side, right? For some emulators you've written, is that correct?
That is right. Yeah. So in my other passion is reliving the glory days, as far as I'm concerned, of 8-bit microprocessors in sort of like the late 80s, early 90s. And so I took particular pride in taking something which I grew up with as a child, which was both the Sega Master System, which was the 8-bit console before the Genesis came out, and the BBC Micro, which was an 8-bit processor that was only available in Britain, where I grew up, and seeing how fast I could write an emulator in JavaScript. And it's embarrassing to say that even a badly written emulator, as mine are, in JavaScript on a modern computer will run at full speed quite easily. It's just, and it's a lot of fun. It's if no one's ever written an emulator before and is wondering about it, it's one of the most rewarding things you can do, because you hack on something for a few hours, you get the first instruction emulated, and you kind of run the ROM, and you're like, oh, yep, I can see that the registers are changing. That's exciting, and you keep going, and a couple of days in, suddenly you're running a whole new game or something that you never wrote, right? I never wrote Altered Beast for the Master System, but I could play it suddenly, even though I had nothing to do with it. It's just really rewarding, and then suddenly all these other games start working, and before you know it, you've got a library of games to play from, and the warm glow of having made it possible yourself.
That sounds cool.
Is that done in pure JavaScript or using Emscripten?
It's actually done in pure JavaScript.
Oh, really? Okay.
I did look at Emscripten, and I have also looked at handwriting ASM.js, which I'm told is insane. And it is. It's almost impossible to get right. It's the browsers will very quickly drop back to going, oh no, I don't know what this is. If not everything is in place for ASM.js, and that's been a wonderful journey, actually. So joking aside, like to actually get it to not take a whole CPU on a fast computer to run does take a bit of doing, and I tripped over a whole bunch of performance issues, and the guys, particularly at Mozilla, the Firefox team, were amazing at responding to bugs. I just tweeted somebody randomly saying, "Oh, this seems to be slow," and before I knew it, I'm exchanging emails with Alon Zakai, and getting stuff fixed, and he's filing bugs on my behalf, and I'm sending him snippets of code that sort of show up pathological behavior in the browser, and they're fixing it like two or 3 days later, and it's out and released. And like, wow, this is how open source should be, and this is awesome.
That is awesome.
Wow.
Okay, well, Matt, I'm not sure if I have any more questions for you. Is there anything else you wanted to bring up before we let you go?
No, I think I'm good. I very much enjoyed being here. Thank you for having me on.
Where can people find you online?
So my Twitter handle is my name, Matt Godbolt, at Matt Godbolt, and my blog is at xania.org. And just Googling my name is unique enough usually to find most of the stuff that I'm up to.
Okay. Well, thank you so much for your time.
Thank you.
Thanks for joining us.
Thanks so much for listening as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, I'd love to hear that also. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you can follow CppCast on Twitter and like CppCast on Facebook. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode is provided by podcastthemes.com at cppcast.com. Theme music for this episode is provided by podcastthemes.com.